Welcome back, guys. So our topic is thermodynamics. In the thermodynamics, you have to study the main points are thermodynamic systems. The next point is thermodynamic process, then work done, and four most important thing we have to start from first law of thermodynamics. The next one is second law of thermodynamics. Thereafter, heat engine, refrigerator, Carnot cycle. So these are the topics, actually question-wise topics in thermodynamics. But Carnot cycle and heat engine. So it is a removed syllabus for this 2024 and 25. So up to 22, there will be every exam in mains. There will be one question on Carnot cycle. Okay, that is out of matter. So coming into system, the system is nothing but the where the properties of gas, pressure, volume, temperature, and energy are changing. Coming into, there are four types of system mainly: open system, closed system, isolated system, homogeneous, and heterogeneous system. In our general example, to understand the system, surrounding, and boundary. System, surroundings, boundary. So if you take this system means example, consider one gas cylinder. So in that gaseous system, gas with closed piston or closed rubber cork, a closed piston and cylinder. That is system. The walls of the cylinder is boundary, and remaining things surrounded by that boundary is called surroundings. Means system and surroundings are separated by a wall is called boundary. So these walls maximum are adiabatic or diathermal. Adiabatic walls of boundary walls. Adiabatic or diathermal. So you'll understand this in coming topic, is coming points. So in the system, we need to study some terms, that is state, path, process, and cycle. State means representing the pressure, volume, and temperature of a matter at one instant. So whereas this pressure, volume, and temperature are changing, so that changes are represented by the path. So this is called now process. This process is repeating itself, means this process is the number of processes are going on like this: A, B, C, and again C, A, or anyway, any cycle, any shape, the changes can happen, and it is coming into the same state as initial state. It is called cycle. That's why that process is called cyclic process. So next topic, that is. So my point is state, path, process, and the cycle. State means representing the pressure, volume, and temperature of a system at one instant. The changes are represented by the path. So these changes, how they are changing, means which property of this pressure changing or volume changing, pressure, volume changing. So that will be representing process. Means isothermal process, adiabatic process, isobaric process, isobaric process, isochoric process. So which one? Cyclic process, quasi-state process, quasi-static process, which process that is. So that will be given by process. And if these processes are continuously changing, series of processes, after series of processes, it is coming into the same initial state, that is called cyclic process or cycle. So coming into this is introduction about thermodynamics. These are important points. First of all, system. That means where you are observing the pressure, volume, means it is the background or reference, knowing about the pressure, volume, and temperature. How these pressure and volume, temperature are changing with respect to other references are called surroundings. Between the surroundings and system, there is a boundary line, that is called boundary. So now coming into thermodynamic systems, open system, closed system, and isolated system. For isolated system, we can give the example for universe. And closed system is a one cylinder with a piston having the gas inside. Not only gas, any liquid or anything. That is closed system. Open system example is steam generators, or all maximum of all engineering devices are example for open systems. Why? What the difference between open system and closed system means? In open system, both matter and heat exchanges means energy. Heat is nothing but energy work. Means mass is traveling from one place to another place, or changing from one system to another system, or one means system to surroundings like that with the help of energy. That means mass can be converted into energy. So that is open system. The closed system is only energy exchanges. The matter is not move. Matter is not exchanging between one system to another system. So whereas in isolated system, both will not change, both will not exchange. So homogeneous means one phase, means one region or one in nature of gas having the physical and chemical compositions uniformly. So that is homogeneous. If not having uniform, that means pressure, volume, and temperature, energy of one gas in one system. So another system which is having the same pressure, volume, and temperature and energy. So these two are called homogeneous. So it should follow like that means the physical and chemical composition need to be same for the gas. So those type of are called homogeneous. In homogeneous mixture example we can tell vessel in a liquid or iron piece means physical and chemical composition same, it is not varying. So gaseous mixture. So these are example for homogeneous. If it is not uniform or it has more than one phase, that is heterogeneous system. So this is about the systems. Coming into thermodynamic process. So there are isothermal, adiabatic, isobaric, isochoric, cyclic, and quasi-static process are there. Isothermal means temperature constant. So here pressure and volume are changes. The ideal gas equation for isothermal process is equal to PV is equal to nRT. That means this total is constant. K, I can take PV is equal to K. That means P1 V1 is equal to P2 V2. So this is isothermal process. Adiabatic process. No transfer of heat between the system and surrounding. So like in second law also you'll understand this. And generally maximum of the process are adiabatic only. Maximum of the means in our surrounding happening the process transformation of heat and everything is example for adiabatic maximum. So here between system and surrounding no transfer of heat energy take place. So that means dq is equal to 0 here. According to first law, I will explain that first law thermodynamics later. So in adiabatic process, dq is equal to 0. So and the ideal gas equation for adiabatic process is equal to P V power gamma is equal to nRT or constant. nR delta T, that is constant. And P1 V1 power gamma is equal to P2 V2 power gamma, you can write. And in adiabatic process, all properties systems property P, V, T will change. Pressure, volume, and temperature, all three quantities will change according to the depends on system again. Isobaric process. Isobaric means pressure remains constant. That means volume and temperature are varying. So this is given by Charles law, V proportional to T. V proportional to T. Therefore, V1 by T1 equal to V2 by T2. So here isothermal process explaining about the Boyle's law. T inversely proportional to volume at constant temperature. V proportional to temperature is constant pressure is called isobaric process, and this relation is given by Charles law. Coming into isochoric process. So here V is equal to constant. V is equal to constant. So V is constant. P and T are variable. Energy anyhow in all the cases energy is variable. So P and T is variable in PVT terms. So the behavior of the gas, nature of the gas, and about the gas, pressure, volume, T are fundamental quantities to understand the behavior of gas. So like motion of the body, velocity, acceleration, displacement, time, how needed. In dynamics, force, acceleration, mass and acceleration, how needed, momentum. So same light coming into light, the some properties of mirrors is required. Some points means to understand the image formation by the mirror, some points is required. The same then with those points only we can explain that lesson. The same way in thermodynamic process also rounding about pressure, volume, temperature, and energy. These four are the fundamental properties, fundamental quantities required to understand the behavior of gas. This only I want to tell. We'll study all maximum of the problems are belongs to PVT, calculation of P, calculation of E, calculation of T, calculation of energy only everywhere, right? So now PT is varies. That means P proportional to T here, where V is constant, P proportional to according to ideal gas equation. So ideal gas equation PV equal to nRT. It follows all the processes, all the laws, gaseous laws, Boyle's law, Charles law, Gay-Lussac law, and Avogadro's law. They are uh, Graham's law also. So that ideal gas and real gas equation in KTG will study. Kinetic theory of gas, there will study about it. So now cyclic and non-cyclic process. Cyclic process means, as we discussed, cycle means after many series of changes, the system is coming into initial state. Initial state means initial pressure, initial volume, initial temperature after many work done. That process is called cyclic process. So the cyclic process maximum, the representation is, so like this here I have given example, see, for cyclic process. So here this is one cyclic process, this is, and here, and triangle shape also. So that is cyclic process, circle, semicircle, here triangle shape, whatever. These processes are called cyclic process. In cyclic process, the internal energy means in the first law of thermodynamics it will come, that is at the internal energy I will explain there. So the internal energy, so along one path is equal. If there are two processes are there, one is one cycle, another one is another cycle. In the two cycles, the internal energy is equal. So on that one, many problems will come. The internal energy from one process to another process means, for example, here see 1 to 2 in this process and 2 to 1 in this process, internal energies are equal. The work done will be different and energy taken or given to the system is different. Work done is different, but internal energies are same. But whereas work done, it is independent on path in mechanics. But here, the work done is depending on path. Here means line, along the line, and that based on the given quantities in XY quantities also. But internal energy in two processes. So 1 to 2, 2 to 1. For example, here A, B to C is one process, and C, D, A or ADC is one process. ABC and ADC. ABC is one way of work done, and ADC is reverse process. Then the internal energies are same there. It is not cyclic process there, right? So that is cyclic process means in any one direction. A, B, C, D, A or ADC, B, clockwise or anti-clockwise. So these points you have to remember. So some problems I'll give on that. This point only. This point what? Internal energy is equal along two different path, right? But work done will be, internal energy is same along two different path, but work done will be different, right? First of all, what is work done? How will calculate the work done? Means if we are doing work on system means what changes will happen, and system how it is doing the work means work done by the system means what, work done on the system means what, if work done on the system what will changes, work done by the system how the value will change, those and all. First after first law of thermodynamics, right? Coming into first law of thermodynamics, so heat is given to the system. Example will take melting process or boiling process. So already in thermometer we studied that. In melting process, the ice is converting into water. So there whatever the energy you are giving means heat energy you are giving, from 0 degree centigrades of ice to 0 degree centigrades of water, there is no change in the temperature. Means no work is done. The total energy given it utilized to change its state. That means increasing the potential energy, internal energy. When the ice is reaching, all the ice is melt and reaches to 0 degree centigrades, then after you are continuing the giving heat, then temperature rises for the water 0 to some up to 0. Ice is at some other temperature than 0. So total ice melt and become a water up to 0 degree centigrades. There is no change in temperature. The total energy utilized to change its state. That is called latent heat of heat. We studied there. So that is internal energy. Then external work done means what? The work done is the given heat used to change the P, RV, RT. Getting? The work done is to change the P, V, or T values. So that this work done is called PdV. P into change in value. PdV only. A constant value, constant pressure work done is PdV. So PdV can be changed into different parts again, different formulas that we'll discuss later. So du in all the process, isothermal, adiabatic, all whatever 6 processes, du is equal to same, that equal ncv delta T. There is no other doubt. So here cv. So I am not going to explain about much about this cv, cp and r. Only required formulas I will give, that we will discuss more about in kinetic theory of gas. So cv means the molar specific heat at constant volume. Cp means molar specific heat at constant pressure. The ratio of cp by cv is equal to gamma, and cp is always greater than cv. That and all we discuss. We will explain. I will explain in kinetic KTG lesson. Right. Cp minus cv is equal to r. That equal to 2 calories. R value 2 calories are 8.314 joule by mole Kelvin inverse. Otherwise, 4.2 joules enough. Right. The Cp I can write as Cv plus R also, because Cp minus Cv is equal to R. Therefore, Cv plus R is equal to Cp. So these are only required in thermodynamics. So I have given. So now coming into here. So dq is the heat given or absorbed by the system. Heat is given to the system or the system is giving to the surroundings. So anything. So when heat is given to the system, then Q is positive. We will consider. So Q is negative when heat is absorbed from the system or system is released to surroundings. Q is, it is a heat energy. Heat energy. So no heat transfer from system to surroundings or surrounding to system, then Q is equal to 0. Change in dq is equal to 0. No work, no change in heat energy, not transferring right now. Therefore, in adiabatic process, dq is equal to 0, that we discussed. Coming into PdV, PdV means P into Vf minus Vi. So work done. Work done means what? PdV. P into Vf minus Vi. So where Vf is more increased than initial value, that means the work done by the system. System is trying to increase, means pushing the piston out or trying to escape from the balloon. Okay, in that case, yes, work done is positive. That means where volume is increasing, work done is positive. Where volume is decreasing, work done is negative. That means work done on the system. Means you are weighing the piston, more weight you are giving the piston, then it will be work done is negative. Work done is negative. So now based on these two values, internal energy du is equal to dq minus dw, right? Du, ncv delta T, it is always. So I hope in first law of thermodynamics, dq, the given energy, is the law is applicable to energy process in nature and applicable to three processes of matter. Means it will be take place. First law of thermodynamics is observed in solids, liquids and gases. The law is introduced to the concept of internal energy. Internal energy is sum of kinetic energy plus potential energy. So as I said, melting process, boiling process cases. Now, and it is telling that we cannot get the work without giving the energy to the system or from the system taking energy. We cannot done any work. Means there is a work exists when heat is given or energy given. Or there is a work exists when energy is taken. So the energy is given or taken is not completely converting into work done. So it will be utilized to change the state, that is internal energy, sum of potential and kinetic energy. So now we will study work done. So work done first dW. Let consider one. So these lines are for drawing. When I am drawing like this side scheme, don't consider them. So the third topic is work done. Let P1, V1, T1 are the initial states of this gas, considering a cylinder with a piston. Now it is in equilibrium state. Now by means changing the volume, the piston is moved upwards. So delta X. So the final volume is equal to V plus initial volume V plus A into dx. A is the area of the cylinder. And this piston is movable only. And in quasi-static process, that I forgot, so I am explaining that. So here see the piston have some weights and the initial state of pressures are P1, V1 and T1. So now slowly small piece you are removing, then piston will rises to some height, delta X height, and there again it will become into equilibrium state. If vigorously or suddenly you are taking the weights, more weights, then maybe the piston will come out, gas exits and leaks out. That also can be possible. If not like that, this is closed vessel. Only mobile piston only is moving up and down with the help of small hole. So in that case, this piston will oscillate up and down when suddenly the changes will happen. But slowly you are removing means after changing one more one more place, it will be get equilibrium. So that is explaining about the quasi static process. So equilibrium, succession of equilibrium state, right? So you came to know there will be a value is changed, final value v into a plus dx. And you can question here, what about the pressure? Pressure is constant. In this example, pressure is constant. Here, pressure is not constant. In this example, I removed some small weights, but here the pressure is constant. The pressure is vary means how the work done calculation that will be different. So like work done by the constant force, work done by the variable force, how we have studied. Here also same. The work done by constant pressure, work done by variable pressure will study. Work done by constant pressure here, dW. According to work done example, F into dx. That is, in this case, work is done by the gas on the system here. That too here on the system. Means here work done, sorry, work done by the system, on piston. By the system. System means I said the consider here gas. Gas is the system in this case. This totally the system. The walls of the cylinder are boundary. Surroundings, piston and above atmosphere surrounding and all surroundings. I hope you understand, I think so. So now force into dx. Force means pressure into A, area, into dx. So PdV will come. And here value is changing from Vi to Vf. Any values are given means PD, work done is equal to integral work done. So initially there is no work done, 0. So finally there will be a work done by the gas on the piston, that is W integral Vi to Vf. Therefore, anyhow this is work done by the system. That's why positive only will come, because value is increasing, right? Work done on the system, value decreases, so it will be negative. So Vf minus Vi. Vf more means positive, Vf less means negative. That is clear. So same work done in isothermal process is also PdV, integral PdV you have to follow. Adiabatic also integral PdV. Wherever work done, they're asking isobaric, isochoric. But when PV graph is given, so work done is equal to area under that graph is called work done. So here I am trying to explain the work done on ideal gas in different processes. This is isobaric process. How I am telling it is isobaric process means the pressure is constant, but volume is changing from one place to another point. At one point, another point, volume change. Vi to Vf. And we know where pressure is constant, V proportional to T. Therefore, V1 by T1 equal to V2 by T2. V is equal to Nr by P into T. V proportional to T, where pressure is constant. So this is isobaric process. The area under this graph, P into constant pressure value, P into Vf minus V over. If they are not given Vf and Vi values, T and temperature changes is given from one point to second point. Temperature they mention. At constant pressure, temperatures. So similarly, here Ta, Vi means Ti, Vf means Tf. T graph also same like this will come at constant pressure, because V proportional to T, right? Right. Coming into here, Pi and Pf, Pi, Vi and Vf. So this is the first state and second state. So here one way they are changing the pressure and value, one graph and second graph, first graph and second graph. You see, this is the process. We don't know this process is what. Means it is not a isobaric, very clear that is, because pressure is not changed. It is not a isochoric also, because volume is also not changed. Volume is also not constant, so changing. So it is maybe adiabatic or isothermal. So how we will find out it is adiabatic or isothermal. So when in explanation of adiabatic process it will come, but here about the graphs work done on ideal gas I am discussing, so I am giving a small idea. So based on the graphs given, so maximum they will represent here, that is this graph is changing the relation between P and V, changing PV power gamma or PV power N or PV, like that it will give. If not given, only these two curves are given, then how to find out which process is and which graph, which line represents which process? For that, take the slope of this PV graph, which one have more slope, more steeper than other one. The most steeper graph is for adiabatic, representing adiabatic process. The less steeper graph line is representing isothermal process. That relation will come in next concept I will explain. So remember up to that. So these are cyclic process. Cyclic process clockwise means work done is positive, anti-clockwise means work done is negative. So that you remember. For example, see here, the PV graph is given here. Here PV graph is given. So this is VA and VD values, the A point and the D point. So VA and VB are same. VA is equal to VB. The same way VC and VD also same. Therefore, the process or line representing, the process means I said representing the path changes of state. At A, one state of pressure and volumes, PA and VA, and TA, temperature. Similarly at B. But A and B values are same, therefore it is isochoric process. Isochoric process. In isochoric process, volume is constant, work done is equal to 0 will come. PdV. Volume is not changing now. Work done equal to PdV. the area under PV graph, so is 0 in AB only, not in the cyclic process, not in this process. So in cyclic process also N internal energy is 0. Okay, NCV delta T is 0, not work done. But work done is 0 in isochoric process because volume is constant. NCV delta T internal energy is 0 in cyclic process as well as isothermal process. So these all points I have tabulated down. We can understand here by seeing this, by pausing this table. Here everything I explain. So about this table in points in middle coming, I am explaining that. So now come to here. In these graphs, how to calculate the work done. First of all, you have to see which process it is. There du, dw and dq. How they are changing. So the energy, total energy means we will find out the net energy dq is equal to du plus dw in all the process. From A to B, dq is how much? In A to B, dq is equal to only du, NCV delta T over there. Delta T means NCV into TA minus TB, that calculation. Because here I know only pressure values, PA and PB. So TA, TB I am changing into pressures. And CB value will write, depends on the gas, ideal gas or triatomic gas or diatomic gas. Based on that, CB value FR by 2 will write. Generally will write FR by 2. Therefore, FR by 2 into PA VA minus PB VB. So this is PA VA minus PB VB. So here NR and here NR get cancelled. Only F by 2. F by 2 into the P is constant. Now here PA and PB, sorry, V is constant. VA VB is constant. So take out V and PA minus PB will be there. Similarly, C and D points also. I hope you understand this. So here VA and VB same. So take out VA common. F into VA by 2 into PA minus PB. Similarly, in a CD process also DQ, the net heat energy. Work done asking means only dW you have to find out. Energy, heat energy means you have to find out dq, q of all the process. Here dq is how much. Here dq I want to find out. dq is equal to pdv is there here, p into pb into v2 minus v1, means va minus vd or vb minus vc, both are same only. We'll find out. But here it will be vb minus vc, and in this case vd minus va. So in this v2b work done equals 0 will come. Okay, work done will be 0. So total in cyclic process work done is only means work done equal pdv will become 0 in cyclic process if all the values are equal, right? So that in the questions we will study. Only remember that area under this graph, PV graph, is given the work done, PdV. Internal energy is NCV delta T, whatever the process. And dq is equal to heat energy is equal to du plus PdV. So this is remember. So here some important models are there. So process is given cyclic process in anti-clockwise direction. Yes, here circle is given anti-clockwise direction. Anti-clockwise direction means negative work done, right? Clockwise means positive. Cyclic process is clockwise means positive, anti-clockwise means negative. So here I have given, see, the cyclic process is anti-clockwise, negative, clockwise means positive. Here anti-clockwise is given. Therefore, energy should be negative. So here work done. Work done is energy here. Work done how to find out. So area under PV graph. So here area is equal to area of the circle, that is equal pi d square by 4. Here d square I will write as P2 minus P1 into V2 minus V1. So here also same. That is P2 minus P1 into V2 minus V1. D square value. Pi d square by 4, pi d square by 8. D I have taken as P2 minus P1 into V2 minus. In all the problems like this only you can take. But nowhere explanation are given, that is pi d square by 4. Simply they have taken pi by 4 into P2 minus P1 into V2 minus V1. So this pi d square by 4, it is my explanation. Right. If you to remember for how this formula is coming means I am remembering in that way. For that only I am given. There is no explanation, nothing, right? Right. So here also coming into this example. So if you see here, work done from 0 to 4 to 3 and 0 is one process. That is anti-clockwise process. As the same way 0 to 2 to 1 to 0 again, that is another process. So this is clockwise process. This is anti-clockwise process. Means the energy should be subtracted here. Depends on maximum and minimum. We can subtract. So calculation of work done means what we will do here. It's a cyclic process, right? 0, 4, 3, 0 is cyclic process. So that's why 1 by 2 and triangular shape. Therefore, area of the triangular shape is equal to 1 by 2 into dV minus dV into dP, right? PdV. Changes P means from here in this process, the change in pressure is equal to P3 minus P 0 or P4 minus P 0 and change in value means V4 minus V3. The cyclic order means anti-clockwise cyclic order. Similarly, here also from work done from 0 to 1, 0. So calculate 2 work done will come. So subtract means you will get the answer. 750 joules is the answer. So this and all from the given data, 1 liter of gas is given there. So 1 liter of gas will convert into meter cubes because the answer should come in joules. So we'll change that given data into required units and all, So here given data is given. V2 minus V1 equal to 10 liters is given. V3 minus V4 is equal to, we have to find out, for finding the V3 minus V4, V2 minus V1 is given 10 liters. So I will go with, to find out V3 minus V4, I am writing like this. The changes in the ratio of the change in values is equal to ratio of change in pressures, right? Difference in the pressure is equal to difference in the value. By that I will get V4 minus V3. So this is one type of model. And we are coming into the pressure changes. Pressure equal to alpha V square. Asking to find out the work done. So work done means PdV, and P is changing here with the volume, right? For example, here P is changing with any temperature is given. P is changing with beta T square or beta T cube like that. So the T we have to change into V again. For example, P proportional to P is equal to alpha T is given. It is changing. So now what I have to do, this T I have to change into V because PdV only is there, right? Work done means PdV. So the T value have to change into V value, then only I can integrate it. Otherwise, alpha and T are, here P is variable. It is not constant to take out, right? P is variable means P need to change into V, right? Variable. So here, but P here in the given question, P is equal to alpha V square, P changing with alpha V square. So I am writing here alpha V square is not a problem at all. But T is given means you have to change. T is equal to PV by NR again. The PV by NR. Okay, now here this P is initial pressure, that is constant, PV by NR. So that you will write. Atmospheric pressure will write. And here alpha value is given data. Alpha value 5 atmosphere per meter cube is given. Convert into pascals. 5 atmosphere convert into pascals. You will get like this. And alpha means here the volume is equal to first initial volume Vi is equal to 1 meter cube and V2 is equal to 2 meter cube. So PdV, T value I am substituting here. So alpha V square into T. So I will write. So here one more doubt you will get. Here P is equal to alpha T is given in the T, changing PB by NRT means PB by NR. So Rn V is there, okay, no problem, dV. But what about the P? P is equal to initial velocity, otherwise constant pressure they will give, that you have to find out. Otherwise this changing is no need, right? The T converting into PV means here also P constant. This is constant pressure. With temperature, this pressure is varying, that this pressure is converting into P naught values. So that depends on the case only we can find out, right? So now this is. And the curves of this PV graphs. For isothermal means PV is equal to constant. For adiabatic means PV power gamma. I will explain all this process. PV power gamma is constant in adiabatic. In a polytropic, that is PV power n is equal to constant. If n is equal to 0, if you substitute, so that is equal to P constant. P is equal to constant, that is isobaric process. N is equal to 1 is substitute, PV is equal to constant, that is isothermal process. N is equal to infinity means change that one, and V by infinity. This is P power infinity I want to means 1 by V power. V power in n I want to there, therefore change into n value infinity want to come means it will be go down, V power 0, therefore P by V will come. So that is one process. And n is equal to gamma, if I am substituting means n is equal to gamma value, that is adiabatic. So I will explain how n value substitution and in polytropic in next concept. Now, so up to this, these are the example and work done calculation when constant pressure and volume graph is given. So cyclic process is given also, I have to change it into PdV. So now work done in isothermal process, because it's given isothermal, directly you can find out in work done. Means is given a graph or gas is isothermally expanding or compression they have given means we can use this formula directly, that is nRT into ln V2 by V1, Vf by Vi, right? So V2 by V1 means sometimes they will confuse in the question the volume 1 to volume 2, they are changing from 1 meter cube to 2 meter cube, therefore 2 meter cube is the V final and 1 meter cube is the V initial. From where to where? From where to where it is changing, that is initial final, like that you can remember. V to V1 don't go. So this is from where to where, that means where initial one is initial volume and final volume, right? So how we will get this formula? nRT work done is equal to nRT into V2 by V1 or Vf by Vi or Pi by Pf means this is the formula. Work done is equal to PdV, we know very clear. So here in the place of P, nRT by V will write. So now nRT dW is equal to nRT by P into dV. So integral dW is equal to nRT into V1 to V2 or Vi to Vf, you can substitute. So ln of V2 by V. So ln we are changing into logarithm, log, natural logarithm and decimal logarithm, log 10 base 10 and log base E, this is natural logarithm, exponential. So now we have to change this ln into one factor, multiplying by one factor, that equal 2.3023 into nRT of log 10, V2 by V1. Because we know log 10 values only logarithms will study. Otherwise in problem they will give NL value or log 10 value they have given, you have to check. Ln value they have given means directly will substitute. Log values you have given means for answer you have to multiply with 2 into 3.203. So that is, I have to check once. And so in isothermal process, you know, T is constant, P and V are variables. Therefore P1 V1 equal to P2 V2. Because T is constant now. Ideal gas equation, PV is equal to nRT, nRT constant. N is number of moles. So in kinetic theory of gas, I will explain all those things. N gas and R is gas constant, number of moles to gas constant and the temperature. So nRT is constant, P1 V1 equal to P2 V2. From that this one will come. And slope of isothermal process is P by V, tan theta equal to P by V. So now coming into adiabatic process. So in adiabatic process, Q is constant. All P, V, T are variable. So in isothermal only PT are variable. In isobaric, VT are variable. In isothermal, PV are variable. Boyle's law, Charles law, and Gay-Lussac law. So now PVT are variable. So now the gas is expands or compression. Gas is expands adiabatically. In Carnot cycle, this isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression is very important in calculation of total heat energy by efficiency. There, this process expanding or compressing. The gas expands adiabatically. Adiabatic expansion is there means temperature decreases. Or internal energy also decreases. Temperature decreased means T2 minus T1, NCV delta internal energy. That is also decreased. Gas compressed, then internal energy or temperature increases both. So in this adiabatic process, our ideal gas relation P and V are how they are related, TV how they are related, or PT how they are related. That we are going to discuss now. The relation between TV, PT, and VT in adiabatic system. So before going to work done, here I have given work done subheading. But before going to that, first law of thermodynamics apply here. According to first law of thermodynamics, dq is equal to du plus dw. Dq is equal to 0 anyhow in adiabatic process. So du plus dw equal to 0. Du is equal to ncv delta T and dw equal to pdv is equal to 0. So now ideal gas equation you take. PV equal to nRT is the ideal gas equation. This differentiate this equation. Then you will get PdV plus VdP is equal to nR delta T. Differentiation with respect to time. Okay, na? dV by dt. Therefore, from this equation, nR delta T is equal to PdV plus VdP by R. So this n delta T substitute in this equation. So I have given 3 in 1 substitute. So Cv into n delta T I am substituting this value plus PdV is equal to 0. So now multiply now Cv PdV and PR dV. So now PdV take common, Cv and R will come. Cv plus R into PdV plus Cv into VdP is equal to 0. So now Cp, the Cv plus R is equal to Cp, I can write Cv plus R, I can write as Cv. Therefore, Cv plus R is equal to PdV and Cv plus VdP equal to 0. Then Cv by Cv, Cp by Cv into P by V is equal to minus dP by V. So dP by dV is adiabatic slope, P by V is isothermal slope, and Cp by Cv is gamma. Therefore, now we can tell the slope of adiagraph is gamma times of slope of isothermal. Therefore, more steeper. Adiabatic graph is, or slope is more steeper than isothermal curve. So now start substituting these values. The gamma into P by V. Gamma into P by V is equal to dP by dV. So dV bring this side and P bring this side. This equation will come. You will get this equation. So gamma into this equation will get. So now integrate both the sides. You will get gamma into ln of from V1 to V2, P1 to P2. Log at V1, P1, P1 to P2. So now gamma in means we know A into log M or log B is equal to log of B power A. Log of B power A. So like that V2 by V1 will come and log A minus log B also formula substitute here. So that and all by this time you must know. So log of A minus B, log of A minus log B, log A minus log B is equal to log A by B. Log V2 minus log V1 equal to log of V2 by V1. Here also log of P2 by P1. This is V2 by V1 and here minus is there. So that is P1 by P2 will come here. So here minus, right? So this gamma will come V2 by V1 whole power gamma. Therefore multiply now P2 V2 power gamma is equal to P1 V power gamma. Means P V power gamma is equal to constant in adiabatic process. This is the relation between PV. So now change them into PV, change into PT. Because in the place of V I have to write, you have to eliminate the V. That equal nRT by P. So to eliminate P, you will write V equal to nRT by 2 we can write. Right, this is nRT by P. Now P into V power gamma, nRT power gamma by P power gamma is equal to nRT whole power gamma by P power gamma is equal to K. So nR is constant value. So therefore P into 1 minus gamma, P power 1 minus gamma and T power gamma is equal to K. If you want to change relation, you want to get the relation between V, T and V or V and T. So eliminate P in this equation, P V power gamma equal constant, eliminate the P value. So according to ideal gas equation, P equal nRT by V. that will substitute means T into V power gamma minus 1 equal to K. So this is means TV are given, or I want to substitute in the place of VT or in the place of TV. So T V power gamma minus 1 is equal to constant I will type. So depends on the given question only, this and all I have to utilize, and you have to remember these relations and all. Now finally coming into work done in adiabatic process. So work done as usual, work done equal to dW is equal to PdV. Integral dW from 0 to W at V1 and V2. At V1 work done equal 0, at V2 work done equal W. Therefore W is equal to, this is the formula, nRT into V power gamma minus 1 by 1 minus gamma. Now V power gamma minus 1 or 1 minus gamma. So that I can write like this, V2 by, so here V2 upper limit and V1 is the lower limit. So V2 of 1 minus gamma I can write V2 by V2 power gamma minus V1 by V1 power gamma. Multiply here and divide P2 by P2, P1 by P. Now I will get P2 V2. This P2 V power gamma is equal to constant, that is equal to nRT. So this constant and P2 V power gamma get cancelled. So P2 V2 by P2 V2 minus P1 V1 by 1 minus gamma. So now in the place of P2 V2 again, if you apply this, nR into T2 minus T1 will come according to ideal gas equation. PV equal to nRT. Therefore nR into T2 minus T1 by 1 minus gamma. These are the work done formulas in adiabatic, work done formula in isothermal, and work done formula in isobaric PdV, and work done formula in isochoric is 0. Okay, all the process I explained. And cyclic process work done is equal to sum of all the works, sum of the works in all the process, sigma of work W1 plus W2 plus W3. And cyclic process means the closed path. So there will be a isobaric, isochoric, isothermal or adiabatic. Depends on that which process is there, that you have to add. So coming into this table, then I will end and explain remaining problems I will explain in next video. Next part 2 I will explain the problems only. So now thermodynamic process I have given in one table. Ideal gas equation for this all the process. Isobaric means P is constant, then V value will be like this, V proportional to T. Isochoric, V is constant, for P is proportional to T, remaining constant, NR by V is constant. So this is Gelu-Sakala. Here it is P is constant, V proportional to Charles law. And isothermal, T is constant, PV is equal to nRT. So there is no explanation, that is ideal gas equation. Isothermal, adiabatic PV power gamma is equal to constant, and polytropic PV power N is equal to constant. So as usual, so now coming into in polytropic process. So whereas polytropic process means, so already in polytropic process, PV power N, the relation between pressure volume is given, PV power N is equal to constant. Find out the work done. dW is equal to integral V1 to V2 PdV. In the place of P, C by V, V power N, right? So this is, you will get C into V2 power minus N plus 1 by 1 minus N minus V1 into 1 minus N by 1 minus N will come. So as usual in adiabatic process, what you have done, the same thing here. The volume change, P2 V2 will come and P1 V1 will come. So that is nR into T2 minus T1 by 1 minus N. For N mole of gas, work done equal to nR delta T by 1 minus N. 1 mole of gas, so that equal to R delta T by 1 minus N. So here if you want to write, this is Tf minus Ti. This is nR into Tf minus Ti by 1 minus N I am taking. So if you want to write, it is same thing in Ti minus N minus 1. In some of the book they will write N minus 1 or 1 minus 1, but changes is Ti minus Tf by N minus 1. Here 1 minus N, N minus 1. Tf, Ti, Ti, Tf. That is the change. So now specific heat. And specific heat is equal to, we know C is equal to, specific heat C is molar specific heat is equal to Q by N delta T. For 1 mole of gas, Q is equal to C delta T. According to first law of thermodynamics, C delta T is equal to Cv delta T plus R delta T by 1 minus N for 1 mole. This is N is equal to 1 mole for gas. So now C is equal to Cv, you know, relation between Cv and Cp and gamma. C, in that Cv is equal to R by 1 minus gamma, and here it is R by 1 minus N. So now if you substitute N value is 1, 0, infinity and gamma. N is equal to gamma. So then specific heat is equal to 2R by 1 minus gamma. 2 into R by 1 minus gamma will come, specific heat form. That is adiabatic process, specific heat. So now already I informed that N is equal to 1, it is isothermal. Isothermal. So then specific heat is equal to R by 1 minus gamma only remaining, Cv only remaining in isothermal. In isobaric. So in isobaric means N value 0, means P is equal to constant, isobaric. In isochoric, we will go with P power N is equal to constant. So P power 1 by N, V is equal to C power 1 by N. So now N is equal to infinity sub 2, then V will become constant. P power means N equal to infinity, where N is equal to infinity, then C is equal to constant, V is equal to constant. That is isochoric process. And N is equal to gamma, isothermal process. Means a polytropic process depends on the N values. You can tell it is isobaric, isothermal, or adiabatic. You can find out isochoric. So this table is very important in solving the problems related to graphs, right? So in everything I have given work done, du, dw, and first of thermodynamics I will write for all the cases. In cyclic processing, du is equal 0. Du is 0 in two cases. One is isothermal and cyclic. Remaining all cases it is NCV delta T. The work done is 0 in only one case, that is isochoric. The remaining and all work done formulas. Isobaric means P into V2 minus V1 or NR into T2 minus T1 or NR delta T. Isothermal means nRT into log of Vf by Vi or nRT into ln of Pi by Pf. Adiabatic P1 V1 by P1 V1 minus P2 V2 by gamma minus 1 or nR into T2 minus T1 T1 minus T2 by gamma minus 1. That also you can write. So here I forgot to write, that is right, we can write. And first law of thermodynamics is 0. du plus dw is 0. Heat energy is 0. So like that, when polytropic means P into dV, that equal just now I have given nR into T2 minus T1 by n minus 1, will write, simple that is. Or P1 V1 minus P2 V2 by gamma n minus 1 in polytropic process. So your polytropic process, when pressure is given like this, pressure and value, P equal to A plus BV, this is the relation, changing, variable pressure. So now work done equal to A plus BV into dV, that will substitute means you will get answer. And in cyclic process, Q net is equal to Q of all the process, and W net is equal to sigma W work done of all the process. Means which process involved according to the graph, given graph. PV graph is given, and PV graph is given means there are two processes are there. One is isochoric process and isobaric process. And in PV graphs, means cyclic process means that is only. In some cases, Carnot cycle means isothermal expansion adiabatic. Any cyclic series of process can happen, right? So some of the work done you have to find out, some of the heat energy you have to find out in cyclic process. So this is about thermodynamic process and all. Maximum I tried to explain only concept here, and out this process where we'll use this work done, this table where we'll use. Next video I'm going to make. So there I will maximum try to explain about the maximum formula related questions, right? Right. Thank you all.